Welcome to Study Guide Forum. Today we are going to be looking at another question that has to do with alternative to practical chemistry. That's for GCE exam that's coming up. Now, before we go ahead, if you have not subscribed to our channel, we encourage you to do the subscription and then you pay attention as we go through this thing together. Don't just be in a hurry. Just cool down and so that you'll be able to get the basic information on how to solve questions like this. So in this question, it has to do with volumetric analysis. In the question, we have the question seems to be um, redox titration. In this redox titration, we have 0.779 gram of potassium permanganate per 250 cm cube of solution, and then the B is the solution of um, ammonium ferrous solution. Then in the analysis, this is the record of the titration. In alternative to practical, they will give you something that looks like this so that you fill it up because you are not expected to do the titration, the practical itself. So this is the record from the result of this um, volumetric analysis or titration. Then this is the table. In the first reading, we have 24.80. The final reading there, the initial reading was 00 and the final reading is 24.80. The second reading we have 34.50, and then here is dash. They expect you to put something there. This other place they expect you to put something, and the final volume of A used is what 24.00. Here the final reading is not given, but you have initial reading which is 6.55, and then the volume of the A used is what 24.1 or 24.10. So they said that the first question there said complete the table. Complete the table. So that's the first thing we're going to do. To complete the table, what we do here is that that since we normally subtract, you subtract 0 from this, from 28.80, we will have 24.80, we have 24.82. So to get the value that we have here, we will subtract 24 from here, from 34.80. If we subtract it, we will have what should be here will be 10.50. That is what should be there. So in this case, to get the value of this, what we do here is to add up. We add these two together. If we add them up together, we have 30.65. That is what we have here. So we are done with that now. The next question there is what? Calculate the average volume of A used. The average volume of A used. To get the average volume of A used, note we don't normally use the first titration. The first titration is considered to be the rough. And meanwhile, if you look at it, you find out that the second and the third is very okay for usage because they are very close together. So then what we do here is we add them up together and divide by 2. That is the average, since there are 2 there. So what we do here is the average volume will then be 24.00 plus 24.10 all over 2. So what we divide it through, what we have will be 24.05 cm cube. That's the volume, the average volume of A used. So the next question there is calculate the concentration of A in mole per dm cube. Now to calculate the concentration of A in mole per dm cube, now we'll look at what we have here. Let's take this position. Since we are done with this, then I think we can clean this zone. So the concentration of A mole per dm cube. Now note you have this in a 250 cm cube. So what we do here is that we'll convert this 250 cm cube to what? dm cube. So to convert to dm cube, it simply means 250 over what? 1000. Then we have 0.25 dm cube. Is that okay? Now we know that concentration, which is C, is equal to mass over what? Volume. Mass over volume. So since it's mass over volume, the mass we have there is 0.79 over volume, which is 0.25. So when we divide it through, using our calculator, we have a divide by, what is this? Divide by, what we have is 3.16 gram, can say, per dm cube. This is not the end of the calculation. It's not the end of the calculation. The next thing we do here, now we have the mass. We know that moles. Mole is equal to what? Mole is equal to what? Mass over what? Relative molecular mass. Actually, what we did here, this is when this is concentration in mass. This should be concentration in mass, concentration in grams per dm cube. Per dm cube of the solution. That will give us mass over what? Volume. That will give us mass over volume. We have a gram per dm cube. That's what we have here, not the concentration in mole. Now for the concentration in mole, now we know that in mole, or if we have to go by that, we know that concentration in mole is what? Amounts over what? Volume. Now when we get the amount, which is moles, we have a 3.6 divided by relative molecular mass of potassium permanganate, which is 158. That will give us, divide by 158, we have 2, and we have 0.02 moles. 0.02 moles. Now we have the amount now, which is 0.02 moles divided by 1 dm cube. That will be 0.02 mole per dm cube. That is what we have for the concentration of A in mole per dm cube. So the next thing we are going to do now we have the mole concentration of A. The next thing we are going to do is to calculate the concentration of B in mole per dm cube. In this case, in the concentration of B in mole per dm cube, we are going to be using the normal relation. Let's see if we can clean this place. So the normal relation, which is CA VA over CB and VB equal to their mole ratio. From here, you find out that the B is what? 5 and the A is what? 1. So then the next thing we are going to do, the next thing is that the volume of this is equal to the A. Here is supposed to be A over what? B, and which is equal to their mole ratio, which is 1 over 5. And then let's continue. Concentration of A in mole per dm cube is what? Is 0.02. And volume of A used is what? 24.05. Then concentration of B the mole per dm cube, we don't know it, but the volume is what, 25 from our question. Then the ratio is 1/5, the mole ratio. Now the next thing we do now, we can cross multiplying. If we cross multiply this and that, what we have will be, so if we cross multiply, that means we'll have 25 CB equal to 0.02 times 24.05 times 5. So CB will then be 0.025 times 24.05 times 5 all over 25. So by doing this, what we'll do here is, what we'll multiply through, multiplying them through, we have 24.05 times 5. We have a divide by 25, we have 0.0, we can say 0.096 mole per dm cube. Mole per dm cube. This is the concentration. We were able to get this thing. Now the next question, they say that concentration of tetrahedral sulfur 6 ion in mole per dm cube of B. That is a very exciting one. That one is very, very exciting. So to do that now, what we do here is that we come over to this end. Let's see what we can do with this column or this space we have here. So we'll come over to this end. Now, from that equation, the true chemical equation there is what we have, the compound involved, we have ammonium, and then ion, ammonium for ferrous ion plus what, 6 water. Actually, when this ionizes, we will have the major component that we ionize there will be ammonium ion, ion 2 ion plus tetrahedral sulfur 6 ion. Tetrahedral sulfur 6 ion. Now, looking at this, you find out that 1 mole of this of ammonium ferrous solution compound will give us, we ionize to give us 2 moles of tetrahedral sulfur 6 ion. So for that reason, what we do here now means that if we have 1 mole here and this other one give us what, 2. So from what we have here, 0.096 mole will then be equal to 2 times 0.096. That will give us what we have here will be times 2. It will give us 0.096 times 2 to give us 0.912 mole. So that is what we have for the tetrahedral sulfur 6 ion. The next one we have here, the next question we have to handle here is what? The last one is the mass of what? Tetrahedral sulfur 6 ion in 250 cm cube of B. So looking at that, what we're going to do here, since we have everything we need, you notice that you notice something here. This is in dm cube. So what it simply means here is that 1000 cm cube of tetrahedral sulfur 6 ion in solution will give us, contain this one. So it has a 0.192 moles. So 250 cm cube of the same ion will then be 0.192 over 1000 times 250 over 1. So that will give us, what will give us will be, let's divide it through, we will have, it will give us 0.041 0.0481. Let's check it. We have 1 divided by 1000. Okay, all right, it's correct. So we have it to be moles. This is the moles contained in what 250 cm 250 cm cube. We have this mole. So we're talking about the mass. We know that to calculate the mass, calculating the mass simply means, since we have this as our thing, remember moles is equal to mass over relative molecular mass. So that would be mass will then be mole, number of mole, which is 0.0481 times the relative molecular mass of the ion is what, 96, multiplying through, we have 4.618 grams of what, the trace of a cis ion. All right, thank you so much. This is where we call it a day for this question, and thank you for coming this far. If you have not subscribed, we encourage you to do that. Leave your comments. If you have any comments, you can also leave it in the comment section. Share and like. And if you want to talk to us direct, you can also go to description column or section of this channel. You can visit our Facebook page, where you can also access us via calls. Thank you so much for being part of the class, and goodbye.